I'm going to copy the graph from 38. And here it is. And I see a couple of points, negative 2, 4. I see negative 1, 2. I see 0, 1. And that's it. And here's the graph. This is the graph of f. I'm going to ask 2 questions here. Number 1, is this function 1-to-1? Yes, by the, yes. So f is 1-to-1 by the horizontal line test. Therefore, does it have f inverse? Because it's 1-to-1, therefore, it has f inverse. We're asked to graph it. Also, find the domain and range for both. I want to find the domain and range for both first. So the function f is defined on, can anyone give us the domain of this function? It's a very popular function. We're going to get to it in chapter 4. Hopefully this semester. Excellent. What is the range of this function? Nothing, 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 nothing. Oh, maybe. 0 to infinity. What will be the domain of f inverse? Zero to infinity. And its range? Very good. It's the absolute reverse, right? So from A, I get to B with f. From B, I get to A with f inverse. Is that okay? Perfect. Good. So we established the domain and range for both. Now I would like to graph it. What do I know about the graph of f and f inverse? They are symmetric with respect to, and I have to graph it with a line, with a line, with a line, y equals x. And now please give me a few points so I can graph the inverse function. 4, negative 2. Perfect. 2, negative 1. Perfect. 1, 0. Notice one thing. Can you please tell me where will you reflect this point? Please reflect that point with respect to y equals x. Where will you reflect it? It's exactly where it is. It doesn't go anywhere. It's on y equals x. So if I say 1, 1, reflect it. 1, 1. Right? If I say 2, 2, reflect it. Where will you reflect it? It's 2, 2, right? Still the same point. Very good. Questions? Yes, please.
So both x and y switch, but the sign does not.
Both x and y switch and what?
The negative sign for x and y, like the symbols for x and y.
So f takes negative 2 to 4. F inverse takes 4 to negative 2. F takes -1 to 2. F inverse takes 2 back to -1. Better? Perfect. Okay. Back to page 309. I would like to look at 44. Okay. A lot of questions here, but actually the same questions. Find the equation for F inverse. Graph F and F inverse on the same coordinate system, and use interval notation to give the domain and range for F and F inverse. Okay. We know transformations from this chapter, and I know right away, I don't have, in my dreams, I will graph x minus 1 squared. How do I graph it? Where is it? Yes, and where does it go?
It's going to go 1 to the right.
1 to the right. Very good. So the base function is this. This is x squared. But I have x minus 1 squared, which I know moves 1 to the right. This is x minus 1 squared. We agree? So why I'm asking this is because I want to establish the domain and the range. Can anyone give us the domain of this function? Before you answer, I want to point here. And can anyone tell us why? This is a polynomial function is defined everywhere. Why is this domain, we say, truncated to 1 to infinity? Can anyone explain why? The horizontal line test is not going to be 1 to 1. So this particular function, we are told, is defined on this for that particular reason. Because by the horizontal line test, this will not be 1 to 1. But I am specifically told, oh, wait a minute, the domain is 1 to infinity. So you have to tell me 1 to infinity. Now please tell me the range. Absolutely. I have no idea how the inverse function looks like yet, but I know its domain and range. Blindly. Absolutely. Absolutely. I don't know the function. I don't know what it is. I don't even know how it looks like, but I know its domain and range. Right? Good. So now I would like to determine, find its, you can graph first if you want, and then find the function. It doesn't matter. Or find the function and then graph. So I prefer graphing first. This was just a side graph for me. This is not important here. I'm just writing this on scratch paper to think a little bit and see what happens here. So now I know that I have to graph when x is 1, y is 0. When x is 2, 2 minus 1 is 1. And I have the graph. This is the graph of f. No questions asked here. I hope you have no doubt. I have enough points. I know how to graph the inverse function. First, I have to draw y equals x. Make sure that what I graph is symmetric with respect to this line. And please give me a couple of points.
0, 1.
Absolutely.
And 1. No, negative.
So this is 1, 2. And this is 1, 0. So I want 1. I want 2, 1. This was 2, 1. I'm sorry. So I want 1, 2. Because it didn't match. Where does this point go?
Stays.
Nowhere. Yes, it goes nowhere. I have the graph, I have the domain and range, but I don't even know what function this is yet. Okay? Symmetric with respect to y equals x? Okay. What is the first step towards finding the F inverse. Step 1, what do I do? Replace F with Y. So Y equals x minus 1 squared. 2.
Swap X with Y.
Excellent. X equals Y minus 1 squared. Now I have to solve for, exactly. Look at this equation and say, oh, I know from chapter 1 what to do with this to solve for Y. Very good. Apply the square root to both sides, and I get Y minus 1 equals, and I cannot forget a crucial part, plus or minus the square root of X. Finally, I move 1. And now, I'm going to ask myself, which one? These are two functions.
Why is it -1?
Because when I move -1 to the other side, it becomes positive. Now I'm asking myself which one, because these are two functions. One is 1 plus the square root of x, and the other one is 1 minus the square root of x. And it cannot be two functions, because that's not going to be 1 to 1. How do I know it's the plus? Excellent.
Because it's going in a positive direction. I don't know, that's one way I can think about it.
Good question. This will tell me. That's why I established this first. Of course, x has to be greater than 0, because otherwise I cannot take the square root. The answer must be a number greater than 1. That's the outcome. So which of these two will I have to pick, and which one I completely disregard? Right. And I'll say only F inverse 1 plus the square root of x. That's why I established the range and the domain, especially the range in this case, from the beginning. The answer must be a number from 1 to infinity. 1 minus the square root of x is not a number from 1 to infinity. Because when you plug in 4, 1 minus the square root of 4, which is 2, 1 minus 2 is -1, and it's not in here. Any questions? Any questions? The last thing we have to go through in this chapter is 2.8. Distance formula. We know this from the previous course. I'm just reviewing this part. Let's suppose I have 2 points, point A and point B, and I want to determine the length of this line segment. I'm going to draw a horizontal line, I'm going to draw a vertical line, and I'm going to form a right triangle. This. And if there is a way of determining the measure of the leg and the measure of this leg, then I'm in good shape, because I'm going to say the distance squared equals 1 leg squared plus the other leg squared using the Pythagorean theorem. But I have to come back and identify that point A has coordinates x1, y1 as being the first point, and x2, y2 as being the second point. So this is x1, obviously. That's the point, right? x1. This is how much? This is x1. This is x2, right? So this is x1, right? And this is x2, because that's how I created the point. So then what is the length of this leg? Must be this minus this. Bless you. Very good. And of course here, this minus this will give us this, which is y2 minus y1. So then I know what to fill in here. It's x2 minus x1, y2 minus y1, and both of them are squared by the Pythagorean theorem. So finally, when I take the square root, I have x2 minus x1 squared plus y2 minus y1 squared. And no one can simplify that any further. We cannot take the square root from a plus b and write that this is the square root of a plus the square root of b. That would be incorrect. So this is the distance formula. This is how I determine the distance between 2 points. Now, there is also a point right here in the middle, denoted by uppercase M, which is the midpoint. And the midpoint is determined, you can determine it with triangles and so on and so forth, but it's the average of x values and the average of y values. Average meaning sum of x1 with x2 divided by 2, and then y1 plus y2 divided by 2. Give me 2 ordered pairs. Any ordered pairs from the book or not, doesn't matter. Give us 2 ordered pairs that you can think of. Some negatives in there should be. So we want 5 and negative 9. And the other one, negative 1 and 7. So we want 2 things. We want to find the midpoint. Please add up the x's.
So 5.
4 divided by 2, 2. Please add up the y's. Negative 2 over 2, negative 1, and that's all about the midpoint. And now I want to find the distance. I write the formula. x2 minus x1, everything squared, y2 minus y1, everything squared. You know me already. I'm going to put these numbers x1, y1, x2, y2 underneath. So x2, negative 1, x1, 5, y2, 7, y1, negative 9. Please do not come up with any negatives under the square root. It's not possible. Those quantities are squared. So please tell me negative 1 minus 5 is? Negative 1 minus 5 is negative 6 squared. Very good. Plus 7 minus negative 9, 16 squared. Now let's put it in the calculator. I'm going to add them up. I don't have to do anything else. So 36 plus 16 squared, and I got 292. So the distance is the square root of 292. Don't try to simplify. You have to add them. This is it. Yes, please.
Can you separate it to the square root of 6?
When I have a sum under the square root, I cannot separate the radical. I wrote it because I knew that is tempting. It is. You can't do that. You can separate the product, you can separate the ratio, but you cannot separate the sum or the difference. Very good. So now I would like to talk about the circle. Here's a circle. You can say not really. Well, bear with me. It looks like a circle. I'm going to say that this is the radius. I'm going to call this point A, x comma y. And I'm going to call this point C for center, h comma k. Why h, y, k? They chose that a long time ago. They said the center of the circle has to be denoted by h comma k. No reason. Okay. Now, based on what we just had, could I write that r squared equals something squared plus something squared? And what would you give me for that something? x2 minus x1 plus this is the equation of a circle centered at C, h comma k, and radius r. How did we get that? From the distance formula. And now, final thing that we have to do in chapter 2 is practice the circle. So there are 3 different types of problems. Here's one. Let's say 33. On page 319. We are given a center, 3, 2, and the radius is 5. Please dictate the equation of the circle centered at 3, 2 with a radius of 5. I'm ready. 25. That's it. Okay, let's do one more. 37. Same thing. Centered at -3, -1 with a radius of the square root of 3. So please give me the equation of this circle. 3, very good, equals? Very good. Excellent. Okay, second type, 45. We are given this equation. We are asked now to identify the center and the radius.
The radius is 2.
Very good. And the center is? Careful, careful, careful. -3, 2. Now I also want to graph the circle. Here's how I do it. I start by plotting the center. The center is -3, +2. The radius is 2. Up 2 to the north, down 2 to the south, 2 to the east, and 2 to the west. I have 4 points that I created based on the radius of 2. Up, left, down, right. So now this is my circle. Okay, 52. And 52 is x plus 2 squared plus y squared equals 16. Yes, please. Say what?
Could you please repeat the points used for the second?
This one? -3, 2?
No, the points used.
I didn't determine them. I went up 2, left 2, right 2, down 2. I did not determine them. So for this problem, we want to identify the center and the radius.
Radius is
Very good. There is nothing subtracted from y. And if you want to graph this, -2, 0 is right here. 4 up, 4 to the right, 4 down, 4 to the right, left. You can be fancy and determine them. I really don't. Unless I have graph paper, I will not bother with the detail. Okay, last type of problem in this chapter. Let's say 55. X squared plus y squared minus 10x minus 6y minus 30 equals 0. And you can say, what is this? And I'm going to say potentially a circle, but I have to show it like this. And I have to do what to this equation to put it in this format? It's a procedure that I said it's a waste of time to use it for something, but I need it later. And this is what I need it for. Say it again.
Completing the square.
Completing the square. This is what I need it for. Exactly. Yes, I know I tortured you with it a long time ago, but I needed it then so that we don't spend a lot of time now. So, bear with me. What do these two terms need to be added to both sides so I can complete the square x squared minus 10x plus blah? Go through the steps in your mind and say, you have to add this to both sides. 25. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. This is what I have to add to both sides. The middle coefficient is negative 10. I divide it by 2. I get negative 5. I square negative 5. I get 25. I add 25 to both sides. Now, this, and this are here. Where? Very good. Good. Now I have to do the same thing to this, which means I have to add something to both sides. Go through the steps again and say you must add 9. Now this and this and this are here. Good. Now all is accounted for except this, which I have to move to the other side. 30, 9, and 25. 30 plus 9 is 39. 39 plus 25 is, I think it's 64. Therefore, is this the equation of a circle? Yes. What is its center? 30 plus 9, 39. 39 plus 25, 64. So 5, 3. And the radius? Very good. Okay, so let's, we have time. Let's practice more of this because this is the most difficult one. Let's try 60. X squared plus y squared minus 6y minus 7 equals 0. And I'll ask you, is this the equation of a circle? And you can say, have no clue. Wait a minute. What would you do? There is no middle coefficient for x. So this is x squared is done, plus. So y squared minus 6y. I add 9 again. So now these three terms are here. And I have to move 7 to the other side. What do I get? Excellent. So finally the center is, and the radius is. Excellent. See, because we remember that from solving quadratic equations, which I said no, unless you're forced to. But this is what I needed it for. Okay. Yeah, why not 59? X squared minus 2x plus y squared minus 15 equals 0. Say it again.
1.
Yes, I'm adding 1, and now these three are here. Y squared doesn't have a middle term. See, now this does not look that bad. Good. So the center is, and the radius of 4. Okay, one more. Let's say, did we do 57? Maybe not. No. So x squared plus y squared plus 8x minus 2y minus 8 equals 0. Yes, so I add 16 to both sides for this. And now I have them all in here. Very good. And now for this and this, I need 1. And now those three are here. If you forget to put plus, you're changing the whole thing, okay? Y minus 1. So now, this is the only thing that has to go to the other side. So I have 16 plus 1, which is 17, and I'm bringing an 8. 5, yeah. So the center and the radius. Right. And 5. Any questions? Between now and Monday, I'm kindly asking you to solve as many problems as you possibly can from 1 through 105. Pages 323 through 326. All these problems have the answer in the back. All of them will be covered on the test. Of course, I have to choose from those. And on Monday, I would like to review for the test on Wednesday. So the test is a week from today on chapter 2 only. Any questions?